Electricity is one of nature's greatest forces. In the winter of 1943, Nikola Tesla looked out across the Manhattan skyline for the very last time. Tesla had been born into a world powered by steam and lit by gas. But before his eyes, he saw a new world, a world transformed, a world powered by electricity. His world. Whoever succeeded in bringing electric light to every home in the land was guaranteed fame and fortune. And by the early 1880s, the most famous, most prodigious, most fiercely competitive inventor in the world had taken on the challenge. The American Thomas Alva Edison. Edison's dream was to bring electric light to every home in the land. And with his team of engineers behind him and the vision of an electric future ahead, he launched his campaign. The race to bring electric light to the world was to play out in the great cities of the time: New York, Paris, London. Edison's Menlo Park team set about developing a totally different form of electric lamp, the incandescent light bulb. In fact, Edison's light bulb design wasn't all that new or unique. French, Russian, Belgian and British inventors had been perfecting similar bulbs for over 40 years. Edison and Swan's light bulb designs were very similar. Eventually, they came to an agreement and went into partnership to sell light bulbs in the UK. Today, many people still believe that Edison alone invented the light bulb, while Swan has become a footnote in history. Because Edison and his team were about to launch their most expensive and risky project yet. America's first power station generating continuous direct current. But there was a big problem. Edison's network could never be economical in lighting America's new suburbs. They just didn't have the concentration of customers needed to make building these expensive power stations worthwhile. The life and death of Nikola Tesla is one of the most fascinating yet tragic stories of scientific brilliance, cutthroat business, and shocking public relations stunts. The American public may have been wowed by Edison's new direct current power stations, but Tesla was less impressed. He had a dream electricity could be transmitted across entire cities, or even nations. And he believed he knew how it could be done, by using a different type of electric current. Electrical experts knew that the smaller the current sent down a cable, the smaller the losses in it through resistance, and so the longer the cable could be. Tesla proposed using a method of transmitting electricity where the currents could be lowered without a fall in the amount of electrical power at the other end. It was called alternating current. And since the amount of electric power in a cable is its voltage multiplied by its current, increasing the voltage meant the current in the cables could be reduced, and so losses due to resistance would be less.
However, you don't want very high voltages on the order of, say, 20,000 volts coming into your home. So you need to step down the current that is being transmitted over a distance into your home, and to do that you need a converter or a transformer. Alternating current allows you to use a transformer to make that switch from the high transmission voltage to the lower voltage that you're going to use at consumption.
Perfecting the technology to transmit electricity hundreds of miles from where it was generated would mark a huge step towards the modern world. and a wealthy industrial entrepreneur was already developing the solution. His name was George Westinghouse. Westinghouse believed alternating currents was the future, but it had a big drawback. While it was fine for electric light, unlike direct current, there was no practical motor that could run on it, and no one believed there ever would be, apart from Nikola Tesla. This is a Tesla egg. Tesla's solution was ingenious. He fed more than one alternating current into his motor and timed them so that they followed in sequence with each other. The first alternating current energized a coil of wire inside the motor, creating an electromagnetic field which attracted the motor's central moving part to it and then faded. The second overlapping current fed the next coil, dragging the moving part around further before it faded, and the same for the third coil and the fourth. The result was a revolving magnetic field strong enough to make the motor, or in this case his egg, spin. Tesla designed an entire electrical system around this called polyphase transmission. This meant a noisy and smelly power station generating lots of useful alternating current could now be situated away from populated areas. In July 1888, he gathered together 75 of the country's top electrical engineers and reporters to witness a spectacle they would never forget. Brown's plan was extremely macabre. He'd paid a team of street urchins to collect together stray dogs roaming Manhattan. Out on stage, he addressed his audience. "I have asked you here, gentlemen, to witness the experimental application of electricity to a number of brutes." His demonstration involved electrocuting the dogs with DC and AC power in an attempt to show that AC current killed them more quickly. And it wasn't just dogs. Brown went on to make public spectacles of killing a calf and even a horse. And he moved from dogs to larger animals for a reason. He wanted to show that the AC form of electricity was so dangerous it could kill any large mammal, including humans.
The execution of William Kemmler marked the lowest point in the War of the Currents, but it wouldn't quite mark the end, because Nikola Tesla was about to do something that had never been seen before, something so wondrous and daring that it would live on forever in the memories of those who saw it.
Tesla had been developing a method of generating very high-frequency alternating currents, and on May 21st, 1891, at a meeting of top electrical engineers, he demonstrated it.
In an almost magical display of awesome power and wonder, and without wearing any safety chainmail or mask, tens of thousands of volts produced by a Tesla coil passed across his body and through the end of a lamp that he was holding.
Tesla's alternating current was at such a high frequency that it passed through his body without causing serious harm or even pain. His demonstrations showed that if handled correctly, alternating current at extremely high voltages could be safe. The war of the currents had been won by Westinghouse and Tesla. In 1896, a new power station was completed at Niagara Falls, using Westinghouse AC generators to produce Tesla's polyphase current. Finally, huge amounts of power could be transmitted from the falls to nearby Buffalo. And then, a few years later, the Niagara plant was providing power to New York City itself. And today, almost all of the electricity generated in the world is done so using Tesla's system.